So we'll take a little bit of time to discuss what a performance-based assessment is. Now, sometimes we call them performance-based assessments or performance-based learning and assessment, and you often see it abbreviated as PBAs, PBLs, and even PBLA. And specifically what it is it's really a way of trying to use strategies to acquire and apply knowledge and skills your students know through a performance of tasks that students will find both meaningful and engaging. So why would we want to do this? Well, we believe there's got to be a better way to deliver our curriculum. It's got to be better than just those procedures that we just do where they practice, do homework, come back, listen to another lecture, practice homework, do lecture. This provides a way that they can do an authentic task that requires them to use those skills that we need them to learn, but in a meaningful way. And that's the point of the authentic task, is it's going to create a realistic situation that does have some application. It's not just pre-constructed. It's not just some contrived scenario. They're going to use real-world situations to help them. And they don't have to be like earth-shattering. It can be a smaller situation, but it's got a realistic tone towards it. So what could be some pros and cons towards this method? Well, let's start with the cons. Give you the bad news first. Often PBAs are going to take more time. It's very hard to get around this as a fact because it takes time for students to collect data they may need to create what they're trying to do for their final assessment and to actually put it all together and even to present if they're to present their data. It's going to be a larger workload often for the teacher as well because of what you may have to do to change how you grade as well as how students may be working together. However, what you gain out of this is a much stronger understanding mathematically for your students, as well as a way for you to really see what they do and do not understand from the content. And it's not that you're going to do a PBA the entire year for every lesson, for every activity, but what it may become is something that you can use to help better gauge where you can modify your instruction maybe before and after that PBA to hit those areas of strengths and weaknesses of your students. So there's three parts that we often think about when we need to create a PBA. There's the performance tasks, the assessment list, and the benchmarks. So let's start with the performance of task. So the performance task is where you're going to actually come up with the task your students are going to do. They're going to take that content knowledge in the mathematics and we're going to figure out how can we apply it. And the big thing here is we're trying to hit higher orders of thinking, trying to think through what can we do that's going to hit those upper levels of Bloom, often beyond applying, and looking at how can we incorporate problem solving, connections, communication, and even representation within the work that they may have to do for this task. So an example of this, in trying to create an authentic task. So here's one that can be provided. How is the fine for speeding in your state determined? Make a graph that shows teenagers in our town how much it will cost them if they are caught speeding. Excellent graphs will be displayed. Well, why would this be a good performance task? Well, it's authentic because it's based on something that happens to a lot of students. They get pulled over, they get a fine, and they get some number told to them that they're going to have to pay for the fine. Where did that come up with? How was it created? Why is that the case? Well, these are things that students then for this task are going to have to actually research. And so they're going to learn about graphing and trying to apply an appropriate graph to create this while actually learning something that applies to their life. That knowledge then is used to produce something. So there's our higher level. They're extrapolating their knowledge, they're analyzing and synthesizing and producing to create something that relates to them and relates to their peers, while also connecting to the mathematical tasks that we would likely be expecting them to do in, say, an Algebra 1 or Algebra 2 course. So there's two ways we can do this. One way is called the inside-out strategy, where we're going to look for some activity that we can place into it, some mathematical activity we can place into a content or a process. And so we start with the math and try to find the real-world application that can help us with it. The other way is to do the outside-in strategy, which is where we find some tasks or some activity, something that's real world engaging we think that will interest our students, and reverse it and try to figure out, well, where does it fit within our curriculum? Where does it fit within the mathematics that we want to do? And figure out how can we apply it together. So either start with the math and then try to find some real world process that may integrate it into it, and make sure we don't want to contrive it. We want it to actually fit and make sense. Or start with that real world situation and you want to find a way that we can mathematically explore it. Now the second part that you need within this is the assessment list. An assessment list pretty much is an enhanced rubric, and it gives all the requirements of the task. So a student should be able to look through that rubric and know exactly how they're being graded. So if you expect there to be 10 different things that you would look for, all 10 of those things are listed and they each have an assigned value. Not only does it have an assigned value, but you also break it down into, if it's a 5-point, how do you get 5 points? How do you get 4 points? How do you get 3 points? How do you get 2 points, 1 point, or 0 point? Each of those levels has a specific expectation of what's needed to get that number of points. That's actually tangible. The students could understand how to get there. Then the students will use that rubric or that assessment list. They'll grade themselves with it first. Then they'll turn in their assessment list with their product to the teacher, and the teacher will then go through and grade it themselves based on using that same rubric. And they can then take the student grading and the teacher grading, and they can compare them and talk about, well, why did I grade you higher here or lower there, and have a stronger discussion about what it means to get those points and understand how to improve overall performance. So here's an example. Say that they were trying to create that graph as discussed before, and the instructor wanted to do 15 different elements. And in this, we don't have the specific points, but say it was 2 points for each of these elements for a total of 30 points. So a student go through and say, did I get 2, 1, or 0, 2, 1, or 0 for every single one, and get their total. The teacher would then later grade it and then hand this back to the student. Well, how would they know if they got all 2 points for each of these items? Well, it would require the descriptor. So here's the first 3 items described. So here's that item 1, which a second ago said that they use the appropriate type of bar graph. Item 2 was about the starting points and intervals, and item 3 was about titles. So to get all 2 points, they need to use the appropriate type of graph. They need to have the appropriate starting points and intervals. And for the title, it had to be clear and accurate in a relationship between the axes. For 1 point, maybe they didn't use the right graph versus they didn't create a graph, so they got no points for it. So this one, that 0 point probably is not going to be an often one that happens. But you have to differentiate and give some reason for that final category. For item 2, maybe they only gave the right starting points, or they were only using the right intervals. And 0 points would be that neither the starting points or intervals make any sense. Whereas for the title, a title may have been given, but it's not clear or accurate, versus no title being provided would get them 0 points. And you do that for each item, breaking down those points so it would be easy for a student to follow. The final thing that you need is a benchmark. Now people see benchmarks, they think that it's a test. No, it's not the test. We're not doing tests here. The assessment list is your way of grading the students and helping them understand what they learn. A benchmark is an example of high quality student work, so that you can go and say, hey, this is the project that you're going to be doing. Here's an example of what your end product should look like. And the better that quality is compared to what you would grade it, the better your students' work is going to be, because they can say, hey, I did it just like that benchmark you showed me. Why am I getting points higher or lower? And you can say, well, I gave you the highest quality that I would expect, and you're missing this, this, and this. That's where the rubric comes in handy. So having a benchmark that shows what you expect to see from your students with that rubric that would go with it can be very helpful for them to know exactly what your expectations are. And as you do the PBA over time, you'll get other students' works beyond the one that maybe you created in the first place, and they can use that then to say, hey, I know that student, I know what he did, that's pretty cool, and it'll give them a way of thinking through that type of problem themselves.